Veridise does a lot of different things to help you with your security. Besides smart contract audits, we do a lot of work with other parts of the blockchain tech stack, up and down from the infrastructure level all the way to the application level with smart contracts. This includes work on ZK, where we've reviewed ZK VMs, custom ZK languages, recursive verifiers, you name it. We've worked at the infrastructure level at both the execution layer and the consensus layer, helping to secure blockchain implementations themselves across a wide array of different packages that both apply common blockchain building techniques like tools from Substrate or are entirely rolling their execution layer from scratch. So we've been able to help people secure their software across the entire blockchain tech stack. But audits are not the only way that you can keep something secure. At Veridise, we have a great amount of cryptographic expertise, which has been necessary to cover zero-knowledge protocols at the level that we do. And this has allowed us to leverage that expertise to help people with theoretical problems. We can review not just a protocol when it's been implemented, but very technical, novel cryptographic ideas to help you make sure that your system is secure before you spend all the time building it. And finally, Veridise has found that infrastructure projects can benefit greatly from architecture reviews, which help people prioritize their security concerns before they jump right into the auditing stage, saving time and money. So a blockchain architecture review is going to review infrastructure especially at a very high level to help you understand what the threats are in each part of your system. So what is this really and why is it needed? In practice, blockchain infrastructure can be massive. These are not small smart contracts with a size limit. These are large, multi-language, multi-platform projects that have to be incredibly resilient to attacks and highly available with thousands, tens of thousands, sometimes hundreds of thousands of lines of code. It is not, number one, realistic for somebody to review all of that code in terms of time, and it's also not as effective. That's too much for one person to fit into their head and at one time and to reason about in a way that's going to provide you the same types of security guarantees you might get from someone reviewing a small smart contract. So what a blockchain architecture review is going to do is it's going to break down your system into parts that are manageable. It's going to, our analysts will come in and review what the system is supposed to do, review the mitigations that you have in place for threats that you have already considered, and also spend time threat modeling themselves to see what types of possible vulnerabilities and weaknesses might afflict this system. With this in hand, they're able to map out a plan for you about what mitigations are necessary in each part of your system and how they might be most appropriately implemented. Parts of the system that are extremely critical and have highly difficult specifications will probably still benefit from a manual review, but other parts of your system may be very readily fuzzable or better approached by testing while the code is still in development, just due to the scale or instability of the project. So this is going to provide you not just with a plan that you can effectuate that is not just, hey, let's have somebody read this code, but is actually prioritizing based on the risks of your system. But it's also going to provide you with a third-party assessment that when someone comes to you and asks, hey, how do I know that your infrastructure is secure? How do I understand how you are spending the limited time you have and the limited budget you have onto security? You have an answer for them. When we're dealing with an architecture review, we're talking about a code base that is, let's say, unmanageable. What does this mean? It means that the amount of time it would take for you to review this code line by line in an effective security mindset is much larger than the amount of time it takes you to understand the high-level purpose and intent of the system as a whole. And this gives us an opportunity to cut costs and save time without sacrificing security. And the reason is simple. When we do that first step and really dedicate an unusually large amount of time to understanding what is necessary to secure each component of your system, this then lets us prioritize on the critical portions. So this does two things at once. First of all, security analysts get context from your code base. They get to spend the time that would normally already be spent at the beginning of an audit to threat model and understand the main workflows. So we're already kind of reusing time that would be spent in an audit. But now, instead of forcing some auditor to commit to a scope well in advance before they really know what your system is supposed to do in detail, you can now work with them collaboratively to ensure that the scope is securing the most critical portions of your project and you're getting the highest security per dollar that you could have hoped to. So leading into an audit or even an architecture review, there are several things that you should do to make sure that this is as effective a process as possible and that a bunch of bugs don't turn up and make your audit report reflect poorly. So the first thing, and this is obvious and everyone will say it, to do is test your system. Now, a lot of people feel like they have tested their system or they're not sure why auditors keep asking them test your system. And a lot of this has to do with the way that testing is performed. When you're looking at tests and when you're writing tests for your system, it's important to test that things work the way you expect. But on the flip side, you want to check that things also don't work when you don't expect them to. And this is an important kind of testing that will outlaw a large number of bugs from popping up during a security review and can be done very effectively by your developers who understand what checks you have implemented in your system and why they implemented those checks. So the first thing right off the bat is not just testing, but testing for negative adversarial potential scenarios. The next thing that is really a big deal is documentation. Now, there are two areas where documentation is going to be really critically important because it's not always just strictly better adding docs to your code. The first area is when parts of your code are genuinely confusing. If you have hotspots of lots of variables, long functions, complex control flow, systems that pass between each other in sort of mutually recursive patterns, please document that. People are going to have a much easier time reading that if you explain to them how it's supposed to work. But the second thing is to document the high-level architecture of your system. And what you want people to be able to understand from this is, how do you expect users to use your system? What users do you expect to be using your system? And what important guarantees are you trying to provide to those users? So this is going to be an accelerant for the audit or for an architecture review, because when an auditor or an analyst comes into your code and they begin the process, the very first thing they're going to ask themselves is, what is this supposed to be doing? And if you have that written right there, that's going to speed things up for them. I'm going to sound like I'm repeating things here, but I promise I'm not. The most important thing, or most common mistake we see people make before starting an audit is not testing something. And what do I mean here? I don't just mean, oh, there's a scenario that they haven't tested. I mean, we got to right before the audit and you realized, oh no, I have things I still want to add into the code, or I want to make a large change to improve something. And what winds up happening is when you make those large last-minute changes, you miss out on the testing phase in a way that is going to insert bugs into your code. And this isn't something that, may lead to problems. Almost always this will lead to problems. So before you go to an audit process, make sure you allocate time specifically for testing, where you are able to freeze your code ahead of the review and then focus on finding problems yourself. And that will make sure that when the review itself actually begins, lots of highs and criticals don't pop up.